This lesson deals with supplemental problem 410. You can find this problem in the ECE302 ebook in the Chapter 4 Supplemental Problems on page 17. Given the circuit below, which has one N-channel MOSFET, 3 resistors, one of which we know the value, and a plus and minus 5 volt power supply. Could you pick the resistors R sub D and R sub S such that this voltage is 1 volt when the drain current is 1 milliamp if K were 200 microamps per volt squared and the threshold voltage was 1.8. Because we've got a difference of 10 volts across these 3 elements, I'm going to guess that we're in saturation, and then we'll check our assumption. Here's my gate, source, and drain. Let's label the things that we know. We're saying that this voltage needs to be 1 volt when this current is 1 milliamp, and of course that's the same current here because nothing comes into the gate. If we're assuming saturation, this is our saturation equation for biasing. And we can solve for the gate source voltage by dividing by K, taking the square root of both sides of the equation, and then bringing this on the other side. With the square root, we have a plus and minus root. The drain current is 1 milliamp, K is 0.2 milliamps per volt squared, and the threshold voltage is 1.8. We'll have 2 solutions from this. One is 4.036, and the other is minus 0.436. But to be in saturation, the gate source needs to be greater than or equal to the threshold voltage, which is 1.8 volts. This is a contradiction. This is the value of our gate source voltage. Let's solve for the resistors. The resistor R sub D, we know the current through it is 1 milliamp. The voltage across it, divided by this current, would be the value of resistance. Well, we know this node voltage is 5, and this node voltage is 1. That makes this 4 volts. Dividing that by 1 milliamp, we get 4K. Do the same thing here. We'll solve for the voltage across this resistor, and then divide by the current. Let's find this node voltage. It's going to be minus the gate source voltage, and then minus 0 times 50K. It's going to be a minus 4.036, and then this node voltage is minus 5, so it'll be a minus 5. That gives us 0.964 divided by 1 milliamp, and that's 964 ohms. Lastly, we need to check that we're in current saturation. Let's find the gate to drain voltage. The gate voltage is 0, back to ground because I have no current coming in here, and then the drain voltage we actually set to 1 volt. The difference of those two is minus 1, and that's less than threshold, which is 1.8. Our gate to source is greater than threshold, our gate to drain is less than threshold, we're in saturation. And this is the biasing of an N-channel MOSFET and a supplemental problem 410.